This is the video explanation for the second test of the Summerfield Open. The first question asks, a McDonald's extra value meal has 1,180 calories. If you run hard, you can burn 700 calories an hour. How many hours of running would it take to burn off that meal? This is an algebra question, and always the best practice whenever you have an algebra question is to define your variable. So let's have B be the hours you have to run hard. So you set up the equation, you have 1,180, and when will that equal 700 calories an hour times B? So when will you run long enough at 700 calories an hour to equal the meal you ate, 1,180 calories? So 1,180 equals 700B. As in most algebra equations, you want to get B by itself. So you can do that here by dividing both sides by 700, and you get 1.69 equals B. That's your answer, and if you want bonus points, you could say 1.69 hours or 101 minutes. Question number 2. A graphing calculator costs $80. You already saved $22, and your weekly allowance is $4. How long until you have enough to buy it? So this is a very similar algebra equation. So the best practice is to say what your variable equals. So A is the number of weeks you need to save up for your calculator. So let's set up the equation. You have 80. And when will that equal the 22 you already have plus the $4 you can save each week times the number of weeks? As with most algebra equations, you want to get A by itself. So the first thing you can do is get rid of that 22. You can subtract 22 from both sides, and you get 58 equals 4A. Then you can divide both sides by 4, and you get 14.5 equals A. So the answer is 14.5 weeks. It will take you 14.5 weeks to save enough to buy your graphing calculator. Question number 3. What is the probability of flipping a coin 4 times in a row and each flip coming up tails? So first we need to know, and this is probably obvious, that the probability of getting tails on a flip is 50%. Now there are a few ways to write 50%. You can write 0.5, you can write 50%, or you can write 1/2. All those numbers are the same and they'll all work the same way. What we'll do is we'll use the ones that work best for us. So one way to think of that is, let's think about your first flip. And why don't you imagine 1,000 people all doing this? So 1,000 people are going to flip a coin 4 times in a row. And we're going to see how many of those 1,000 people get tails 4 times in a row. So your 1,000 people, we're going to take 1,000 people and we're going to multiply it by the probability, which is 0.5. So take 1,000 and multiply it by 0.5 and you get 500. So that means after one flip, 500 people had tails. So after the second flip, we're only going to think about those 500. We're going to do that again. Of those 500 who got a tail on the first flip, how many of them will get a tail on the second flip? We do that again. 500 times 0.5 and 250 people. So going into the third flip, there are 250 people who had tails after the first flip and the second flip. We do it again, 250 times 0.5 is 125. So going into the fourth flip, there are 125 people who got tails on the first flip, the second flip, and the third flip. And then of those 125 people, half will get tails again, so that's 63. So the answer is, when you started out with 1,000 people, 63 of them got tails all 4 times. So you can take 63 divided by 1,000. And that gives you 6.3%. Now you'll notice here, the answer is 6.3%. So it really didn't matter if we started with 1,000 people or 10,000 people or 100 people, because you end up dividing by that anyway. So that kind of washes out, and the answer is 6.3%. You would get 6.3% no matter how many people you started out with. It's just 1,000 is an easy number to work with, so that's something you may want to think about. So 6.3% is your answer. But there's also another way you can do that. Did you notice each time you did that, each event, each flip had a probability of 0.5? What would happen if you took 0.5 times 0.5 times 0.5 times 0.5 for the 4 flips, that would give you 6.3% as well. So that's how you can answer this question, just by multiplying the probability of an event happening each time. Question number 4. Hopefully this one looks familiar from the first test. If you invested $1,000 and earned 6% interest annually, how much would you have after 10 years? So let's start with saying if you invested $100 and earned 6% interest, how much would you have after 1 year? So the interest on $100 at 6% is $6. And then you can say, well, I still want the $100 I started with. So you can take 100 times 0.06, that gives you $6 of interest, and add that to your original $100, and that gives you 106. Now, a way you can do that in one step is just taking the $100 and multiplying it by 1.06. So after 1 year, you would have $106. You can do that again, and after 2 years, you can take that $106 you had after 1 year and multiply it by 1.06, and you get 112. And after 3 years, and after 4 years, and you can keep doing that, and on and on and on. And after 10 years, if you keep doing that, you would have $179.08. So basically, you took 100 and you multiplied it by 1.06 10 times. Now that's a lot of work, and there's a much easier and faster way to do that. Your calculator has a button that does exactly that, the X to the Y button. So what you can do is you can put 1.06 X to the Y 10, and that's the same thing as saying 1.06 times itself 10 times. 1.06 times 1.06 times 1.06, and so on. And so you can then take that answer and multiply it by 100, since you started with 100, and you get your $179.08. Again, this is a really important skill, especially in finance, compound interest, and that X to the Y button is going to be critical as you do this. So I really hope you learn that button. Question number 5. How many different ways can you arrange the letters of the word math? So let's think about that. Your first letter can be an M, an A, a T, or an H, right? That hopefully that's pretty obvious. And there are 4 different ways you can do that. So you at least have 4 different ways you can arrange it. But then let's look at the M. Your next letter can be either an A, a T, or an H. So there are 3 ways, if you start with an M, that you can have a second letter. So 3. And I'm just wondering, math has 4 letters. So for the first letter, there were 4 different ways you can do that. For the second letter, there are 3 different ways you can do that. Let me know if you notice a pattern there. So you can start with M, and then you have 3 different ways you can do that. And that's actually true for each of the letters. If you start with A, there are 3 different ways you can arrange the second letter. If you start with T, there are 3 different ways you can do that. If you start with H, there are 3 different ways you can do that. Now the third letter, let's say you do M-A. The third letter can either be a T or an H. Now notice what we're doing. The first letter, there were 4 different ways you can do that. The second letter, there were 3 different ways you could do that. The third letter, there are 2 different ways you can do that. And then the last letter, if you do M-A-T, there's really only one way you could do that, right? You could do an H at the end. That's the only thing left over. And that's 1. Now notice those letters at the top, 4, 3, 2, 1. They kind of make a pattern that is probably pretty obvious. If you multiply all those together, that will be your answer. So the first letter, there are 4 different ways you can do that. So 4. And then the second letter, there are 3 different ways you can do that. So 4 times 3 is 12. The third letter, there are 2 different ways you can do that. So 4 times 3 times 2 is 24. And then the fourth letter, there's only one way you can do that. 4 times 3 times 2 times 1. And that equals 24. Now there's actually, has a special name called factorial. And factorial is when you multiply a number, like 4, times every number below it. So 4 times 3 times 2 times 1. And your calculator has a button that does that. It's the N with the exclamation point. So if you have a number with an exclamation point, like 4 with an exclamation point, if you press 4 and then that N with the exclamation point sign, you would get 24. And that is really important. This is, when you do a lot of probability, you need to figure out combinations and things like that. You'll use this a lot in probability. So the fast way to find out the answer to this question, how many different ways can you arrange the letters of the word math, is to say how many letters are there? There are 4. Do 4 factorial, and that gives you the answer. All right, the last question, question number 6. A bacteria colony can triple in size, which means it increases 200% every 4 days. If it is currently 1 gram, how big will it be after 20 days? So the first thing we need to do is we need to say 20 days is the same as 5 cycles. So a bacteria colony will triple in size every cycle. Every cycle is 4 days. So if you have 20 days, that means you have 5 cycles. And then you can say, let's do it for the first cycle. 1 gram will increase to 3 grams in the first cycle. So that's 1 times 3. Or actually, we're going to use that compounding button again, the x to the y button. 3 to the first power is 3 grams. After the second cycle, it goes from 3 to 9, which is 3 times 3, or 3 to the second. The third cycle, it goes from 9 to 27, which is 3 to the third. The fourth cycle, it goes from 27 to 81, which is 3 to the fourth. And the fifth cycle goes from 81 to 243, which is 3 to the fifth. So the answer is 243 grams. If it starts out as 1 gram and it triples in size every 4 days, after 20 days, it'll be 243 grams. Now again, you can do that 1 cycle at a time, which we showed you here, but there's a much faster way to do that, and that's using that x to the y button again, and you'll notice we showed it every time. You can take 1, which is what you started with, 1 gram, and you can multiply that by 3, because it triples every 3 for 5 cycles. So you can say 3 to the 5th power gives you 243 grams. Great job, everybody. Again, these tests are not easy. These tests are meant to be extremely challenging for 4th and 5th graders. When I write these, I write them at the 6th or 7th grade level. So even if you get 1 or 2, you're doing a fantastic job. If you get 3 or 4, you're knocking it out of the park. And if you're getting 5 or 6, that means I need to write the test harder. I'm kidding, kind of. Great job, and we'll see you for the next test, which is December 12th or 13th. We're still trying to figure out the day at Summerfield Elementary at 3:15.